Hello everyone, I am Sandeep Chahande. Guys, we are here to learn electrical machine design. So, our today's topic is heating overload ratio and mechanical overload ratio. Okay, we have to derive a relationship between heating overload ratio and mechanical overload ratio. So, let's move forward. So, our today's objective is to learn and to derive a relation between heating overload ratio, that is pH. The heating overload ratio is denoted by P suffix H, and in between the mechanical overload ratio, that is PM. Okay, so the outcomes of today's lecture will be at the end of this lecture. You will be able to discriminate between the terms heating overload ratio and mechanical overload ratio. Along with, you will learn a common relation between them. Okay, so again, so let us see first of all the heating overload ratio. What is the meaning of heating overload ratio? So it is the ratio of losses on short time duty to the losses of rated load on continuous duty for the same machine temperature. As we have seen in the previous lecture, there are three kinds of ratings or three kinds of duty. First one is continuous duty, second is short time duty, and third is the intermittent duty. So here the definition states that heating overload ratio is the ratio of losses on short time duty, that is the loss is represented by the capital Q. Okay, the loss of the machine is represented by the capital Q. So here the short time duty loss can be represented by QSH, where SH stands for the short time. Okay, so as it is stated, it is the ratio of losses on short time duty. So obviously QSH will be in the numerator to the losses of rated load on the continuous duty. That is, here the losses of continuous duty is represented by Q norm, that is the Q nominal or Q normal we can say. Okay, for the continuous duty loss, the loss is considered as the Q norm. Okay, so here we got the relation, that is pH, that is the heating overload ratio, equals to the QSH to the Q norm, where QSH is the permissible losses on short time duty and Q norm represents the losses on rated, that is, or the continuous duty. Okay guys, keep in mind the short time duty or the short time loss is the part of the continuous duty. Okay, means continuous duty is bigger as compared to the short time duty. Okay, you can take out the short time duty time from the continuous duty. Okay, continuous duty is running for the infinite, okay, the indefinite time. Okay, as we have seen in the previous lectures, the continuous duty, there is no any time limit. For the continuous duty there is no any time limit, but for the short time duty there is certain specified or definite time. Okay, so the definite time can be derived from the indefinite time. Okay, so obviously the definite duty or the short time duty can be derived from the nominal, that is the continuous duty. Okay, so here we got the first relation. Now again, moving forward, now using the basic temperature rise equation, as we have seen, as we have derived in the previous lecture, that is, for the basic temperature rise, we have theta equals to theta m in bracket 1 minus e to the power minus T upon Th, where theta represents the temperature, the overall temperature of the machine. Okay, and theta m represents the maximum temperature, maximum permissible temperature of the machine. Okay, beyond that no any machine will be get raised, its temperature don't get rise beyond its temperature, that is the theta m. Again in bracket 1 minus e to the power minus T upon Th, where T is the time of the machine, for how much time the machine is getting run. Okay, and Th is the heating time constant, as we have seen previously. Th is the heating time constant, and its formula is Th equals to Gh upon S lambda. I am telling you again and again, that is Th equals to the Gh upon S lambda, where G represents the what? That is the weight of the machine given in terms of kg. Okay, H is the specific heat of the machine, Again S is the surface area, okay, and lambda represent the specific heat dissipation, that is emissivity we can say, okay. Again moving forward we have, so for the short time rating duty we can write, as we have seen, the basic equation of the machine temperature rise, that is theta equals to the theta m in bracket 1 minus e to the power minus t upon th. So similarly for the short time duty we can consider that is theta sh, where sh stands for the short time quantity. So for the short time rating we have to consider the theta sh, okay, where theta represents the temperature and theta sh represents the overall temperature of machine for the short time rating only, okay. So here we can see, we can write that is theta sh equals to the theta m dash in bracket 1 minus e to the power minus t sh by th, okay. Again tsh is what? That is the short time, for the short time rating of the machine, okay, short time rating of the machine, and th is the heating time constant, that is gh upon s lambda. Th equals to the gh upon s lambda, where you can see theta sh equals to the temperature rise with short time rating at t equals to the ts, as I told you, okay. And the again the notations are mentioned in this slide, as you can see, okay. Again moving forward, so as maximum allowable temperature rise during short time rating, okay, how much will be the maximum temperature of any machine, guys? How much? Okay, so as you can see, any machine, whatever the machine is there, whether it is transformer, that is the static machine, or any rotating machine, it must be having its maximum temperature limit, okay. Beyond that limit, beyond that temperature, it won't be get allowed to raise its temperature. So every machine is having its maximum value of temperature, that is nothing but the theta m. So in that condition, for the short time rating we can consider the short time temperature can be equals to the maximum temperature. So in that case, as you can see the equation 3, that is theta sh equals to the theta m. So from again equation 2 we have to put, that is theta sh equal to the theta m. So instead of theta sh we have put, that is theta m, that is equals to the theta m dash in bracket 1 minus e to the power minus tsh upon th, okay. Instead of theta sh, that is right from the equation 2 we have put the theta m instead of theta sh. So theta m will be equals to the theta m dash in bracket 1 minus e to the power minus tsh upon th. So therefore again rearranging the above equation we can get, that is the theta m dash moves towards the left hand side, so it will be theta m is moving towards the left, that is the right hand side. So we can see theta m dash upon theta m equals to the 1 upon 1 minus e to the power minus tsh upon th. So you can see we got a relation, that is theta m dash represents the what? That is the maximum temperature of the short time rating, and theta m represents the theta m, that is the maximum value of temperature for the continuous rating. So as you can see from the very basic definition, that is pH equals to the short time rating temperature, that is short time duty temperature, to the continuous duty temperature, okay. That is the loss, okay. The loss of any machine is considered in terms of the heat, okay. Whatever the heat is getting lost, that only can be considered as heat. So here we can see the loss of the short time rating is considered for the theta m dash, and for the continuous duty it is considered as theta m. So you can see the relation, that is the first equation, from the first equation and whatever the relation we have derived here, that is pH equals to the theta m dash upon theta m. So that is equals to the 1 upon 1 minus e to the power minus tsh upon th. So here we got from the equation 4, this is the relation of heating overload ratio, okay. Now again moving forward, you can see now the mechanical overload ratio. So the definition of mechanical overload ratio is that it is defined as the ratio of permissible short time rating to the continuous rating of machine, okay. The that is mechanical overload ratio is defined as the ratio of permissible short time rating. Okay, permissible short time rating means rating is represented by the P. Okay, any machine is having means P is nothing but the active power, we can say P stands for the active power, and any machine is having active power, that is represented as the heat loss, we can say. Okay, so PM, that is the mechanical overload ratio, is represented by the PM, and it is defined as the ratio of permissible short time rating to the continuous rating of machine. So PSH, SS stands for the short time, and P norm, that is norm, stands for the normal or the continuous quantity, we can say. Okay, so PM will be equals to the PSH to the P norm. Okay, again heating overload ratio is QSH upon Q norm. Okay, and mechanical overload ratio is PSH upon P norm. So where we can see PSH is nothing but the permissible short time duty or the short time rating, you can say, and P norm is the continuous duty, that is the normal continuous duty. Okay, so again moving forward, we are having, now suppose any machine is having two kinds of losses. Okay, so the first one is the PI and second is the PC, where I stands for the iron and C stands for the what, that is copper. Okay, so the Pi, that is the iron losses, depends on the magnetic core. Okay, so the core losses are generally constant losses. Okay, so the Pi is considered to be the constant loss, that is the iron loss, and again there are two kinds of losses in terms of the iron losses, that is the hysteresis loss and eddy current loss. Most of you have learned in your previous classes. Okay, so again PC is the variable losses, that is the copper loss. Why the copper loss is variable? Because copper loss depends on the current, and the current is depends on the load. Okay, so as the load sometimes get varied, so the current is also get varied. As the current is getting varied, so therefore the copper losses is not constant, so it is considered to be the variable in nature. Okay, so then we have the pH, that is heating overload ratio, can be given as, that is pH equals to the QSH, that is the very basic definition of the pH, that is the ratio of QSH to the Q norm. So that is equals to the QSH can be considered as the losses of iron, that is the constant losses, plus PC in again bracket PSH to the P norm. What is PSH upon P norm? PSH upon P norm is the mechanical overload ratio square. Okay, so overall PS, that is the heating overload ratio, can be considered as QSH upon Q norm, that is equal to the Pi plus PC in bracket PSH upon P norm whole square divided by Pi plus PC, where Q is what? Q is the loss, and overall loss of for the continuous rating can be considered as the Pi plus PC, that is the summation of iron losses, that is constant losses, plus plus the copper losses, that is the variable loss. So again rearranging, we can see that is pH equals to the Pi plus PC into PSH upon P norm is what? That is the PM, that is the mechanical overload ratio definition. Okay, so PM is the ratio of PSH upon P norm. So you can see pH equals to the Pi plus PC into PM square divided by Pi plus PC. So here we got the equation number 6. Again rearranging the equation 6, we can get, now dividing the right hand side, that is the overall right hand side of the equation 6 by PC, that is the copper losses, to the numerator and denominator to equation 6. Why we are dividing? Because we have to cancelize certain term, we have to get certain equation in simple form. Okay, so whatever the quantity, by which quantity we are dividing to the numerator, by that same quantity we have to divide to the denominator again. Okay, so you can see we have to divide by the PC to the numerator and to the denominator. So overall equation can be considered to be normal, the overall equation can be considered to be stabilized. Okay, so pH equals to the Pi upon PC plus PC upon PC into PM square, where PM is nothing but PSH upon P norm, that is the ratio of PSH and P norm. PM stands for the mechanical overload ratio. So again to the denominator, as you can see, Pi upon PC plus PC upon PC. So PC term will be get cancel out, that is equals to the 1 to the numerator and again to the denominator. So we get again that is pH equals to the pi upon pc plus pm square again divided by pi plus pc plus 1. Okay, so that is pH equals to the k plus pm square divided by k plus 1, as here we have considered pi upon pc is equals to certain constant k. Okay, why? Because iron losses are considered to be the constant, so the overall losses we are considering here, the consideration is there, don't be get confused over here. Okay, so pi upon pc is said to be a constant k, so we are considering pi upon pc equals to the k, so pH will be equals to the k plus pm square divided by k plus 1. This is the equation number 7. Okay, I hope all of you are getting this. It is very simple derivation. Once you get start from the very beginning, so you will understand each and everything. So don't miss any video. Okay, so don't miss any lecture of mine. If you have any problem, guys, then you can directly comment in the following section. Okay, any kind of problem you are having regarding the electrical machine design, you can comment in the following section. Okay, and if you want any improvement in my lecture, you can also tell me. Okay, your suggestions are very welcome. Okay, so now again moving forward, we have, so from the equation we can see that is pm square equals to the k plus 1. We are rearranging the equations, we have to move certain left hand side quantity to the right hand side or right hand side to the left hand side. So we are rearranging the equation. It is very simple, that is pm square equals to the k plus 1 into pH minus k. What is pm? Pm is the mechanical overload ratio, and what is pH? pH is the heating overload ratio. Okay, so therefore cancelling out the square term, we can get pm equals to the under root of the overall quantity of the right hand side, that is in bracket k plus 1 into pH minus k. Okay, so pm equals to the under root of k plus 1 into pH minus k. So this is the equation number 8. So as we have considered, the constant losses are the are assumed to be 0. Why 0? Because there is no any consideration related to the iron losses. So we have to consider those iron losses, that is pi equals to 0. So hence the overall k will be also equals to 0. Why? Because k we have considered, that is pi upon pc, the iron losses to the copper losses, as the numerator term, that is pi equals to 0, so overall k will be equals to 0. So therefore equation 8 can be formulated as pm equals to under root of 0 plus 1 into pH minus 0. Why 0? Because k equals to 0. Why again 0? Because we have considered the pi equals to 0. Okay, the iron losses, that constant losses are assumed to be 0. Keep in mind. Okay, always keep in mind while deriving any derivation, you have to consider these considerations. Okay, we have to consider these certain considerations. So therefore equation can be formulated as, that is only what remains, that is pm to the left hand side and equals to the overall term, that is k equals to 0 plus 1 into pH, so that is nothing but the pH, and again minus k, that is equals to 0. So we got only pm equals to under root of pH only. So this is equation number 9. So here we got a relation between the mechanical overload ratio and heating overload ratio. So whatever the mechanical overload ratio is there, that is equals to the under root of pH, that is heating overload ratio. So here we got a relation between heating overload ratio and mechanical overload ratio. Okay, so it is very simple derivation, as you can see, and sometimes it is asked for the 7 to again 8 marks in the examination. Okay, so you have to follow up these simple steps. Okay, so here we have concluded that the relation between the mechanical overload ratio and heating overload ratio. So pm equals to the under root of pH. M stands for the mechanical, H stands for the heating. So the relation, final relation is pm equals to the under root of pH. Okay, so in the next lecture, guys, we will see certain constant quantities, that is the there is heating time constant and one cooling time constant is there. Some basic definitions have been asked regarding the heating time constant and cooling time constant. In the short notes, sometimes it is also been asked. Okay, so let's meet in the next lecture. Okay, so if you are having any difficulties until now, you can ask me in the comment section below. Okay, thank you. Have a good day.